Yeah. Today we'll continue with the multi-threading. Next concept, how to prevent the threads. Preventing the thread means we are controlling the thread execution. How to control the thread execution? Before going to that, we'll see again. Yesterday class, we'll recap some topics. Now, let's take example. I have program 1. Inside program 1, I have main method. In main method, we have for loop. 0 to 100, I am printing the I values. I value equal to 0. Up to 100, I am printing in the first for loop. I have second for loop. In the second for loop, I am printing the values from 100 to 200. So when we execute this, first we are printing the values from 0 to 100. I value equal to 0, I value equal to 1, up to I value equal to 100. After that, we are printing the values from I value equal to 100 to 200. So the program execution is happening from top to bottom in the main method, in the sequential order. One after another, the program is executing, it's giving the output. Now, what is the benefit we will get by using the multi-threading? So now here I have two tasks. First task is printing the values from 0 to 100. And second task is printing the values from 100 to 200. Now here we have two tasks. If you have 100 tasks, all 100 tasks if you put in the main method, first task is completed, then only it will go to second task. Second task is completed, then it will go to third task. Then similarly, it will go to the 100 tasks one by one. One by one it is going means it is sequential order. But if you're using multi-threading, we can execute the task concurrently. What is concurrent? Now if you run it, we'll get the sequential order output. First 0 to 100, after that 100 to 200. Now the same program, I am writing two threads. First thread, class A extends thread. Here I have a run method. Inside run method, I have values printing from 0 to 100. I value equal to 0 to I value equal to 100 we are printing in the task A. In class B extends thread. In this second thread, I am printing the values from 100 to 200. Same for loops we are printing using the two threads. I have a main class program 2. Inside main class I have a main method. Main method also executing based by using the main thread. Main thread is created by the JVM. Main thread is starting by the JVM. JVM will take care of creating and starting the main thread. Now main thread will call the main method internally in the JVM. Inside main method, we are creating object to the thread A and thread B. These two are the we can tell as a child threads. I have created object to the class A. Whenever object is created, the thread state is new state. When we start the thread, after the start method execution, it will go to the runnable state. Similarly, I have created object to the class B and started the B thread. Now, whenever we execute our code, program 2, we'll get the execution in the simultaneous order because both threads are created, both threads started executing simultaneously. Previously example you can see we have first for loop. First after executing the first for loop, we'll get the second for loop output. That is a sequential order. Now if we go to the multi-threading, both threads are created and started. Both threads will start executing simultaneously. Simultaneously means the thread 1 is won't wait for thread 2 execution. Thread 2 is won't wait for thread 1 execution. Both threads are started. Both threads are started and executing our code. Now let's go and run this. We'll get the simultaneous output. First it is printing 0 to 93. After 0 to 93, second state started in between. It's not completed execution of the first thread. In between, it started executing the second thread. So here, since if you use multi-threading, if you have multiple threads, multiple tasks, you can create a thread and you can start the threads. If you take example of previous example, for executing the task 1 and task 2, printing the values from 0 to 100 and 100 to 200, it will take some time of 2 seconds. First one is for 1 second, second one is for 1 second. Now here, if you come to this multi-threading, you created thread 1 and thread 2, both threads are started and executing simultaneously. It might complete in the 1 second only because both threads started at a time. It won't wait for one thread to complete its execution. So it will complete our task very fast if you use multi-threading. To achieve good performance, you can create threads and you can execute our task. Now here if you see, first thread is executing after 55. Second thread started executing. I value is 100. And in between we can see 101, 102. Both are executing simultaneously. If output is coming mixing with the both threads, that is called simultaneous execution. Sequential execution means once first is completed, then second will execute. This won't change. This output won't change. After executing up to 100, from 100 to 200, it will execute. Always. Now, if you see, first it will execute up to 100. After 100 only, it will start executing the second thread. By using multi-threading, we can get good performance. If you have multiple tasks, we want to run multiple tasks at a time. For example, in operating system, we have the computer. In the computer, we have operating system. Operating system will take care of executing our programs. For example, now I am running the Eclipse. Now we want to open the Chrome browser. This is one task. Here I am opening new tab. I am opening some Gmail. This is one task is running in the operating system. And here, this Eclipse is one task. We want to open terminal. This is another task. Now we are doing multiple tasks in the operating system. This is happening using the multi-threading. All multiple tasks we can use simultaneously. If you don't use multi-threading here in operating system, you can't achieve this. See, if you want to play the songs and if you want to write coding in the Eclipse, we can do it because multi-threading is possible in the operating system. If you can't able to do that, that is not called multi-threading. First, Eclipse work is done. You have to close the Eclipse, then you have to open the terminal. That is called sequential. One after another we are doing. Simultaneously, all tasks are running means that is called simultaneous execution, multi-threading. Now we have seen what is a multi-threading in the first two programs. Let's go to the next program. Now here, I have class C extends thread. Inside class C extends thread, I have run method. Inside run method, I am making the seed thread to sleep for 1500 milliseconds. Sleep method is a checked exception type. We have to catch it. Whenever we call sleep method, we are telling to the JVM, just make this thread to sleep for a particular time period which we are giving the sleep method argument. It's mandatory. It will go to the sleep for 1500 milliseconds. It won't continue its execution of the thread. It will go to 1500 milliseconds sleep. After 1500 milliseconds, again it will come and execute the remaining portion. Whatever remaining portion is there, after 1500 milliseconds, it will come and execute this portion. That is called sleep method. Sleep method is we are telling to the OS JVM to make this thread to go to the sleep. Once the time period is completed, then it will come back and it will execute the remaining portion of the thread execution. That is the use of sleep method. We are calling sleep method for 1500 milliseconds. After that, I'm printing system.println of thread.current thread.get state. By calling the getState method, we will get the state of the method, state of the thread. After that, I am calling for loop for 5 times, printing the child thread. Just a string I am printing. Now in public class program 2, I have a main method. Main method is executing by using the main thread. Inside a main thread, I created an object to the class C thread, and I am calling the c1.getState. Whenever object is created for the thread class, the state of the thread is new. This is thread lifecycle. What is thread lifecycle is? To explain the states of the thread is called thread lifecycle. See, when we create object to the thread class, then the state of the thread is new state. When we call start method of the thread class, then the state of the thread is runnable state. After calling start method, if we call system.println c1.getState, it will give the runnable. Once we call start method, internally JVM will start method will be called run method of a class C. It will go and execute the run method. When it is calling run method, inside run method, we are calling thread.sleep of 1500 milliseconds. Now this thread class C will go to the sleep state. Now the thread is in the sleep state for 1500 milliseconds. Now this main thread execution won't stop. Main thread execution will continue. Inside main thread execution, what we are doing is thread.sleep again. We are calling thread.sleep for 200 milliseconds. We call thread.sleep for 200 milliseconds. Then the main thread will wait for 200 milliseconds. The main thread in 200 milliseconds, but here the child thread we are calling the thread.sleep of 1500 milliseconds. Now, after 1500 milliseconds, we see the state of the thread, thread.current thread.getState. It's waiting for 1500 milliseconds, so the state of the thread will be as a timed waiting state. If we call sleep method on the main thread, the same thing for the child thread also we call sleep method for 1500 milliseconds. Child thread also will go to sleep state for 1500 milliseconds. On that time, if you want to get the state of the state of the thread is timed waiting. Now here the main thread is in the sleep state for 200 milliseconds. After that, the state of the thread is here the state of the thread is runnable because the main thread is running. Until the main method is execution is going on, the state of the thread is runnable state. Here we are getting the c1.getState. Okay. Now here we are calling c1.getState. c1.getState is c1.start. Inside the c1.start, we are calling the thread to go to the sleep of 1500 milliseconds. Now the thread state is sleeping state. Sleeping state is we can call as a timed waiting. It is waiting for some time period. 1500 milliseconds it is waiting. Now whenever thread is executing, C thread is started executing the run method. Inside the execution of the run method, we are making the thread as a timed waiting by calling sleep method for some time period. So when we call system.println of c1.state, the thread state will as a timed waiting state. This is called timed waiting. If we call any thread sleep method, then the thread is in the timed waiting state because we gave some time period to make it wait for some time. After that, we'll get the main thread. Now we have seen what is a new state and what is the runnable state and what is the timed waiting state. This is the timed waiting state. Here the state is runnable only because the run method, inside run method, the state is runnable. Now let's go and see what is happening there. See here the first state is new, then runnable, timed waiting. Because C1 dot run method, inside that we are making it went to sleep method, sleeping for 1500 milliseconds. So when we call C1 dot state here, this time period is 200 milliseconds. After that I am calling C1 dot get state. C1 is in 1500 milliseconds waiting state. So we'll get the timed waiting. Then after that main thread, it will give 5 times main thread. Then here it will come and execute the remaining portion after the 1500 milliseconds. So we'll get here as a runnable state. Then child thread. Let's go and run it. Now this is a new runnable timed waiting. And what is the terminator state? Whenever thread execution is completed, C1 dot get state. I'm just making the main thread for sleeping 1300 milliseconds. Then after that, I'm calling C1 dot get state. Until after 1300 milliseconds, the thread C thread has to go to the terminator state. Once the execution is completed, run method execution is completed, then it will go to the terminator state. I want to see terminator state, so I'm giving the waiting on that. See, C1 dot thread is terminator state. Now this is all about the states of the thread. States of the thread means we are explaining about the each and every state. Life cycle of a thread means we have to explain each and every thread state. Now we have seen life cycle of a thread in this example. Let's go to the next example. Now we have to see what is how to prevent the thread execution. To prevent the thread execution, we have three methods. Yield method, sleep method, and join method. These are the three methods which we use for preventing the thread execution. Now let's see what are each and every method. What it will do. Now let's explain the example. Class D extends thread. Inside class D extends of thread, I'm just overriding the run method. Inside run method, I'm just iterating the loop from 0 to 50. Then what I'm doing is I'm just printing system.out.run current thread.get name. I'm printing the name of the thread, and this I'm just appending some string is running now. Now here it will print 50 times. Thread 0 is executing. Thread 0 is running now. Simply we are just printing one message. After that, public class program 4. Inside program 4, I have main method. I have class d1 equal to new d. After creating object, the thread state is new state. d1 not start. After calling start method, it will go and execute the run method. Then it will go to runnable state. Now we are calling thread.yield. Whenever we call thread.yield, what is the use of thread.yield method? By calling thread.yield method on any thread, we are just giving hint to the JVM. We are not doing anything important. On current thread, If any important things happening in another threads, if anything is having high priority, go ahead and run them. By calling yield method on any thread, we are just giving hint to the JVM. We are not doing anything important on current thread. If anything is having high priority, just go ahead and run the threads. Now in our example or any program, we have threads, three threads, T1, T2, T3. I have three threads. First I am executing the thread 1, T1. T1 is executing. When T1 is executing, we call yield method on T1. We are giving hint to the JVM. T1 thread is not that much important. If anything important in other threads, T2 or T3, just go and execute the threads. It is just a hint. We are not telling the JVM, we are not commanding the JVM to stop executing T1 and go and execute the priority threads, high priority threads. We are just giving hint to the JVM. JVM will take the hint as an order or it take the hint as an advice. It will go ahead and it will execute based on its requirement. But we are just giving hint to the JVM. T1 is not being that much important. If you any other threads is having high priority, go ahead and execute other threads. That is called yield method. Now let's go and run this our program. Now we are just calling thread.yield. Thread is main thread. We are calling yield method on main thread. So it won't go and execute this portion. If it is taking the hint as a order. If it is taking the hint as a advice, it will go and execute the first. It will simultaneously execute the both threads. If it is taking as an order, thread.yield, then first it will execute the D thread, then it will execute the main thread. Now let's go and run this. Now we have seen what is the yield method. First thread 0 execution is completed, then only it will execute the main thread based on the hint. The program output may vary. It will give different outputs, but we'll get that end as a main thread only because we are telling to the thread scheduler, I'm not doing very much important in the main thread. Just complete the child thread execution. Take it as a hint, not an order. Once the child thread execution is complete, then come and execute the main thread. Output will come. In the multi-threading, output won't be same. It will change. Now this is about the yield method. We are just preventing the thread execution of main thread and telling just go and execute the high priority thread. If any thread is D thread is here, if it is high priority, just go and execute this. But when we have to use the yield method means we are doing two threads in our program. First thread is taking time of 1 hour to complete its task. Second thread will take 5 minutes to complete its task. Now both threads are executing simultaneously. First thread and second thread. Or first thread and second thread executing sequentially. In case of sequentially, first thread will take 1 hour time. Second thread has to wait 1 hour to complete the 5 minutes task. So by calling yield method, we can tell hint to the JVM thread scheduler, just stop executing the thread 1 because it is taking 1 hour time. First go and execute the high priority thread of 5 minutes task. First complete the task, then come and execute the remaining portion of the current thread. That is called, we are giving hint to the thread scheduler or JVM. Just complete other thread, high priority thread execution first, then come and execute the remaining portion of our thread. That is really method will do. That is called preventing the thread execution. We are just stopping the thread execution of the main thread by giving hint to the JVM and executing the remaining other threads. That is use of thread.yield method. Now let's go to the next method, sleep method. In program 5, implements runnable. I'm just creating thread by implementing runnable interface. Inside runnable interface, I have public void run method. Now inside run method, I'm printing, I'm reiterating for loop I equal to 0, I less than 5, I plus plus. System out of printer now, printing the current thread name and I value. First we will printing the current thread name plus I value in this. After that, I'm calling sleep method on the current thread. This is a child thread. In program 5, this is a child thread. Inside main method execution is happening based on the main thread. Now here we will get the child thread name, thread 0, and I equal to 0 to 4 we will get. When we call sleep method on the child thread will go to the sleep for 1000 milliseconds. Main thread is a main thread, parent thread. Remaining all threads, whatever we are creating in our program, all threads are the child threads. Child thread, we are telling to the child thread, go to sleep for 1000 milliseconds. By calling thread.sleep method, now this thread will go to the sleep for 1000 milliseconds. Now inside main method, public static void main string args. I'm creating object to the child thread t equal to new thread of new program file, and I'm starting the thread t.start. Whenever we call start method will execute the run method internally. Inside run method, we are just printing the child thread and printing the value I. After that, we'll go to the 1000 milliseconds sleep. Child thread will go to 1000 milliseconds sleep. After 1000 milliseconds, again it will come and execute the, because it is a for loop will execute 0 to 5. First it will go to 1000 milliseconds. After 1000 milliseconds, it will come and execute the remaining portion. Remaining portion is, then I will become 1. It will print. After 1000 milliseconds, it will print child thread 1. After 1000 milliseconds, it will print child thread plus 2. After 1000 milliseconds, it will print child threads plus 4. Up to 4, it will print. Now here, creating object to the child thread, one object and starting. Similarly, I'm creating one more object to the child thread. Thread T2 equal to new thread of new program file. So I'm creating two objects of a child thread, and I'm starting. 2 times thread will start. So first, whenever we're creating first object, the name of the thread is thread 0. Whenever we create second object, the name of the thread is thread 1. Now, when we execute it, first it will print thread 0 is thread 0, 0. After that, we are calling thread 2 also. So, second thread name is thread 1, 0 will print first time. After that, both threads will go to the sleep of 1000 milliseconds. After 1000 milliseconds, thread 0, 1, thread 1, 1. Again, both will go to the sleep of 1000 milliseconds. Then after that, thread 0, 2, similarly up to thread 0, 4, thread 1, 4, it will get output. Let's go and run this. After 1000 milliseconds, it is printing thread 1, thread 0. Thread 0, 0, thread 0, thread 1, 0, second thread. Here second thread printing first, then first thread. Similarly, second thread first, first thread. 5 times we are getting the both threads. By using thread sleep method, we are preventing the thread execution for 1000 milliseconds here. If you want to prevent the thread execution for 10,000 milliseconds, we can give the number and we can prevent the thread execution. So by using sleep method, we can tell to the JVM, stop executing the thread 1 for 1000 milliseconds. Stop executing the thread 2 for the 1000 milliseconds. That is preventing the thread execution by using the sleep method. Let's go and see the next example, join method. See, public class program 6 implements runnable. Insert the program 6, public void run method. First, we are getting the current thread, thread.current thread, to the variable t. System.println of t.getName. This we know. To print the name of the thread, we can call t.getName. If the thread is alive or not, if you want to see thread is alive or thread completion is completed, it will enter the terminated state. By calling this alive method, we can find out thread is alive or not. T.is alive. It will give the thread is in a new or runnable or waiting state or timed waiting state or terminated state. If thread is in the terminated state, then is alive is false. If thread is in the other states, then thread is alive method will give the true. After that, I'm just printing the for loop from 0 to 1, 10. Printing the thread name, thread.current thread.getName. Printing 10 times the thread name. Now inside main method, main thread, I'm just creating object to the thread class, program 6. I'm calling the start method. Thread t equal to new thread. I'm calling the start method on the thread 6, program 6. Now whenever we call start method on this, it will go and execute the run method. First we'll get the current thread and it will print t.getName is alive or not. Whenever it is executing, it won't stop executing the remaining portion of the main method because it is multi-threading. This thread will start method will call executing the run method, so it will continue its execution. Even though the run method is completed or not, it will continue its execution. Then here I'm calling t.join method. If you call join method on any thread, join method will tell to the JVM whenever we call join method on any thread, first complete the execution of the current thread on which thread we are calling join method. Then you come and execute the remaining portion of the main thread. Here we have main thread and child thread. Child thread is program 6. We are getting object to the child thread, program 6. And we are calling join method on the program 6. Whenever we call join method on the program 6 child thread, so first it has to complete program 6 child thread execution first. Once that execution is completed, then it will come and execute the remaining portion of the main thread. Whenever we call join method on any thread, we are just telling order to the thread scheduler. First complete the thread execution of child thread first. Then we come and execute the main thread execution. Let's go and execute this and we'll see what is output here. You see here, thread 0. You can get is alive is true. Thread 0 is alive. First we are printing the all thread 0. After executing that, because we are calling join method on the child thread. So whenever we call join method on the child thread, we are telling order to the thread scheduler or the JVM. First complete execution of the child thread, then you can come and execute the main thread execution. Up to here, whatever output is there, everything is related to child thread execution. After that, this is main thread execution. Here, system.println of t.getName is alive. The alive method after execution, complete execution of the child thread is alive is false. So we are getting false here. Then in the main thread, I am returning loop and printing 10 times main thread name. We are printing the main thread name 10 times. After that, the main thread is alive or not. You can just checking. Still the main thread is in this block only, so main thread is alive only. Once it come out of this, then the main thread is not alive. It will give the false. See, it will give same output. Now if you won't call the join method on the child thread, then JVM won't care about which thread is executing first. both threads will execute simultaneously. That is called multi-threading. If you want to prevent execution of the main thread, first complete execution of the child thread, call the join method on the child thread. Now if you call it, you will get different output. See, first it is executing main thread, then it is executing a child thread. Output will become vary. In between some child thread execution came and main thread execution came. We call join method. First child thread has to complete execution, then it will come to the main thread execution, remaining portion of the main thread. The output is same always. That is called join method. By using yield method, we are just giving to the hint to the JVM, just complete execution of the high priority threads first, then come and execute the remaining portion of that thread. That is called yield method. That is we are just giving hint to the JVM. But in case of sleep method, we are giving order to the JVM, just stop execution of the current thread for some time period. After the time period, come and execute the remaining portion. That is the sleep method. What is join method? If your two threads are there, if you want to complete execution of the first thread, then only you can come and execute the remaining portion of the second thread. Call the join method on the thread 1. If you want to complete execution of the thread 2 first, then come and execute the remaining portion of the other thread. Then call the join method on main thread. Thread dot join. For main thread, we have to call the join method on the instance. Main thread, we don't have instance. So we have to create thread main equal to thread dot current thread. Now I want to call join method on the main thread. First main thread execution has to complete. Then only it will go and execute the child thread execution. So let's call this. First main thread output will come. Thread dot current thread. I'm just printing one SOP. Main method is main. Thread is main thread. So let's go and run this. First main thread is executed, then child thread is executed. But here if you see again the output is coming as a reverse. It's executing 2 times. So we cannot call join method on the main thread. Just remember this. We can call join method on the child thread. The output will give same output always. Now if similarly we have program 6 is a one thread. If you have other programs like child thread 1 and 2, 3, 4, 5, 6. 5 child threads are there. If you want to complete execution of child thread 1 first, then you can call join method on the child thread 1. Then other threads will execute. First child thread 1 execution is completed, then only other threads will come and execute. That is called preventing the threads by calling the yield and sleep and join method. We can continue the next concept of multi-threading in tomorrow class. I will update the class timings tomorrow. Tomorrow class timings in the group.